All right, everyone. Today we're going to talk about merge sort, and my name is Austin Harris. So, by definition, merge sort is a recursive algorithm that continually splits a list in half, and then it will sort them. If the list is empty or has one item, it's sorted by definition, meaning the base case. Merge sort is usually kind of categorized with in the divide and conquer algorithms. And it's also much more effective list, unlike insertion sort, which we looked at in our last assignment. So divide and conquer. Since merge sort is a divide and conquer algorithm, we must decide what our sub problems are going to look like. So if we think of like let's say a 4-element array, we first break that array into 2 sets of 2 elements, and those are now our subproblems. And then we reduce those 2 lists of 2 elements down to 4 lists of 1 element each. That's known as our base case. So, and the full problem is going to be to sort the entire array. So, like I said, let's say that the subproblem is sorting the subarray starting at index P and going through index R, and P is the beginning of the list, the beginning index, and index R is the end. So we have array PR that will denote the entire array list. Divide. This is our first step. First, we divide the initial array, finding the number Q of the position midway between P and R. So Q, let's say we use an odd number just to make it easier. We have a list of 5 elements. We'll have P be an index. We'll say it starts with 1. We'll say it's 1, and index R would be 5, and 3 would be Q. So, so the divide step is accomplished by adding P and R and dividing by 2, and we round down. This step is done all the way until we reach the base case, like we talked about in the previous slide, or the single element array. In the image at the bottom of the slide here, we see we start off with a 8-element array, sorry, a list, 0 to 7. We have P and R. That's the starting. That's going to be index 0 for P and index 7 for R. And Q is the middle. That's going to be index 3. 2 lists up, and then we recursively call the same the merge sort again, which continues to split that up until we have base case. You can see at the bottom of the image we have all 8 elements by themselves in their own list. So after the divide step, we move on to we call it the conquer step, by recursively sorting the subarrays in each of the 2 subproblems created by the divide step. So when you think of, you might, it says 2 subproblems. That's because if you think from each step, I'm going to go back a slide, you have 2 below. So if we look at the first line, the first list with all 8 elements, when we split them, we have 2. And then if you look at either one of those are split into 2 more, and then those are split into 2. So that's why it's 2, and this is recursive. So really, each time merge sort is called, it's just doing, it's just dividing into 2 different lists. So after this begins, and we've reached our base case, which is the subarray containing fewer than 2 elements. We have a little misprint there after that. So we recursively sort the subarrays, PQ, and we recursively sort the subarray, Q plus 1 to R. So lastly, we have the combine step. We combine the 2 arrays back into the single sorted subarray. So starting from this image at the bottom, I'll start to merge and sort. So the conquer step, which actually sorts the values, that happens at each step. And as they're put, and then the combined step happens after they're sorted. So you can see 14 and 7, and the first 2 elements are combined, and they're sorted, and they're combined when they're merged. And then we can see that the next level, they're combined again, elements, and then we go all the way to the 8 elements. And that is how merge sort works. Merge sort, the runtime is big O of n log n in all cases, which is a little different than insertion sort that we looked at. The divide step takes a constant amount of time, regardless of the array size. So the divide step that we talked about in big O notation, we indicate constant time by big O of 1. The conquer step, where we recursively sort two subarrays of approximately n over 2 elements each. We will analyze this in the next slide. We'll go over that a little more. And the combine step merges a total of n elements, so taking big O of n time. And lastly, so the divide and combine steps combined together can be viewed as Cn time for the constant C. And below, we can take a look at how the divide, the conquer step, how it differs between how many elements you have. So in this case, we have 8 elements. So if we look at the very bottom right, we see 8 times Cn over 8. So that n over 2 we saw before, that's with 2 elements. So as we can see, that ends up reducing to n log n. And I believe that is it. And that's everything for this time. Thank you.